All right, thank you so much for the introduction. My name is Hao Li. I'm CEO and co-founder of Pinscreen. I'm also associate professor at a new AI university called the Mohammed bin Zayed University of Artificial Intelligence. Today I'm going to speak about distorting and enhancing realities using generative AI. So 30 years ago, there was one particular movie that actually made a huge impact on my entire career. I'm pretty sure you guys remember T-1000 from Terminator 2, where the first time I would see like a liquid metal morphing into different shapes. Basically, what it was telling me is that CGI, or visual effects, was able to do anything that is possible, right? So things that are not possible in physical realities, we can do it using computer graphics. So a couple of years later, we would actually see a ton of movies that would make heavy use of visual effects, right? So one great example here is Avatar. In Avatar, there were over 3,000 shots that were using visual effects or CGI, and only 2 shots in the entire movie didn't have any CGI. So what it means is that CGI is a transformative technology that would change storytelling. So you might think that everything is possible now using these kind of technologies, but one thing that we were seeing back then is that human faces were very difficult to achieve, right? So one of the reasons was that we as humans, social animals, are very sensitive to the human likeness, right? So CGI faces were pretty often very creepy, and people would avoid them in movies. So the phenomenon that we're seeing here is what we call the uncanny valley effect, right? So intuitively, you might think that if we add more realism to computer-generated imagery, then you might find it to have more empathy, right? So on one axis, we have realism. On the other axis, we have likability. If you start with something abstract like Futurama characters or Simpsons characters, and then you go to Pixar characters, you might find them more likable. However, when you get closer to photorealism, one thing that you will see is that because we get more sensitive to it, we might notice everything that appears very bizarre, right? So this is where we have the feeling that something feels like zombies, right? And of course, the ultimate realism is a real picture of someone. So how do we solve this problem? Initially, one of the technologies that still right now is highly adopted in the industry is to use data capture or computer vision, right? So the idea is that we would scan actors using, for example, a multi-view stereo technology, or in this case, a multi-view photometric stereo system, one thing that was used heavily in our labs back then when I was a professor at USC. We would do high-res scans so we can get down to pore-level details using controlled lighting capture, so a technology that was initially developed by Dr. Paul de Bevec. And we would use this technology to scan actors and also capture physical appearance properties of the face so we could simulate these faces inside virtual environments. So the main issue with these kind of technologies is that you need a very complex system, right? It's $1 million system, it's hard to deploy, and not to mention the amount of heavy post-processing that happens afterwards. So 15 years ago, when I started my PhD at ETH Zurich here in Switzerland, used to have the same haircut. And one thing that we were doing was we were trying to think about, can we make facial tracking more deployable, right? So this was way before there were commercial depth sensors. Here's a system with a projector and machine vision cameras. And what you can see is that we were demonstrating that real-time face tracking was possible and highly automatable, right? So initially, this technology was developed to facilitate visual effects and make it easier for artists to use. But something I didn't really expect, but we commercialized this technology and it was acquired by Apple. And the end solution was actually the Emoji technology that you have in your iPhone. So I continued to push the envelope of facial tracking. A couple of years later, I was involved at Weta Digital. One of the projects that we're working on is basically how can we reenact a photoreal person, right? So this was a use case where Paul Walker, who unfortunately died in an actual car accident, we were trying to reenact his face in the film Furious 7. And basically, the idea was we were tracking the faces of his brother and trying to recreate a digital face of Paul Walker. So this technology actually required a lot of human labor, right? So it basically cost like millions of dollars just to do a couple of shots in the movie. So one thing that's really important is that with the breakthrough of deep neural network, we could basically make these things a lot more robust, right? So I'm going to give a quick introduction of deep neural networks. So initially, deep neural networks were modeled using artificial neural networks, so basically multi-layer perceptrons. But one of the big breakthroughs here is to have what we call neural network 2.0, which is convolutional neural networks. Convolutional neural networks basically consist of multiple layers of linear and nonlinear functions. And what it allows you to do is actually analyze an image. That's basically what we use nowadays for face recognition, for self-driving cars. And the principle is very simple, right? So you basically have multiple layers of these neural networks. And given an input image, what it allows you to do is to basically classify into multiple properties, right? For example, given a photograph of one of my dogs, you can basically say, is that a beagle, is that a toy pool, and you can basically provide probabilities for each of these items. Now, we're going to simplify this concept and basically just put this as a deep neural network. So the first thing that we can do is, instead of using a deep neural network as a classifier, we can actually use it as a regression into different, what we call facial blend shapes, right? So different properties of the face when people are doing different facial expressions. So given a video, so this was an early work with our company and NVIDIA, and we're basically showing that it's possible to build a very robust system to track the human face. Now, one thing that is even more remarkable is that if you just track a face, you still have to render the face using a traditional computer graphics pipeline. So what we wanted to do is to think about, maybe we can turn this deep neural network around, and instead of just analyzing it, we can actually use it as a generator to generate images. This is basically the basic concept of generative AI, right? So the idea here is, for example, I want to create a toy poodle, and you can actually generate an image of a toy poodle. Now, if you think about it, one thing that's interesting here is that, well, what kind of toy poodle is it generating? It can be anything, right? So that's actually one of the principal problems of generative AI, which is how do you control it? Anyway, let's do a quick tour of generative AI. So in generative AI, one of the crown jewels, as many of you have heard, is generative adversarial networks, right? So this is a early work that was pioneered by Ian Goodfellow. And the idea is basically to combine two deep neural networks, one that is there to generate and the other one that is enhancing the training of the generator by using a discriminator, right? Basically telling it if it's good or if it's bad. And if you train this network with sufficient data, you can basically have a deep neural network where you can always generate something in this specific domain of faces, a realistic face, right? So this is something that NVIDIA has been pushing the limits. Multiple research papers came out of this. And one of the state-of-the-art methods nowadays are StyleGAN 1, 2, and 3. And what it does is that if you train this network with sufficient data, you can actually generate realistic images of things that never existed, right? So this is really the crown jewel of generative AI here. And this is something you can actually try out, right? So I'm pretty sure you've seen that before. You go on the website, this person does not exist, and you can just constantly generate a new face. By the way, a technology that people use a lot for creating fake identities. So what we did now is we're interested in, manipulating faces and also generate new facial expressions, not just new identities. So one of the technologies that we've developed a couple of years ago is what we call PAGAN, photorealistic avatar GAN. And the idea is that instead of generating a new face, we would actually generate new expressions. So in this example, you can see on the upper right, so here we basically have just an simple input image, and on the left you have a driving video. So we're conditioning the generation of new facial expressions based on a video. So what you can do is you can actually generate plausible facial expressions from a simple person. This technology is just using forward propagation, so it means it works in real time. So here's a live demonstration of how we can use a single camera, a single photograph, and we can overlay another person's face onto a video. So this basically is one of the first real-time deepfake technologies, right? So at the same time, there was the whole concept of deepfakes that emerged that was back in 2017. It was anonymously developed, and of course, the code became open source. So a lot of, you could basically see a lot of viral videos. This is a prominent one created by Chris Ume, right? So it's basically the Tom Cruise deepfake. And in addition to all these entertaining videos, unfortunately, we would also see a lot of use cases where deepfakes were used in non-consensual pornography, right? So a lot of A-list celebrities were targeted, and there was also a study by Sensity AI where 96% of all the deepfake contents were actually porn-related. At the same time, there were also a lot of concerns about what if people would weaponize these technologies, and there were actually a couple of cases recently where deepfakes were used in the context of disinformation campaigns for influencing politics, geopolitics, etc. Right? And of course, everyone is aware that there are also privacy and copyright problems. So another problem is in scamming, right? So obviously, these technologies are highly accessible. They can generate things that appear extremely convincing. Here's an example of a high-profile case that happened earlier this year. So a finance worker actually got tricked by someone who actually pretended to be the CFO of a company. So there was a 25 million transaction that was actually done. And to my knowledge, this was one of the first where audiovisual deepfakes were actually used in a live conversation. And of course, there's also other types of deepfakes that were used. For example, in the Taylor Swift case, this is a different kind of deepfake, which I'll talk about later. This is using diffusion models, where people would actually generate completely fake images of her, and in this case, related to porn images that were spreading virally on Twitter. Right? So 47 million views that were reached in just a few days. So the main problem here is that we now have a technology, as opposed to in the past, that were only accessible to visual effects and production studios. It's accessible to everyone, right? So everyone can generate these content. They're very easy to produce, and you can also generate things that are extremely convincing. So what can we do about it? Well, one of the things is to enhance and to protect ourselves using deepfake detection technologies, right? So we've actually published one of the first work on how do we detect deepfakes, right? So the early technologies were based on biometric type of approaches. So the idea is that we would, for example, record a lengthy video of someone who is known and basically try to match if certain features appear in a new video, and to see if that the movements are consistent with what is known about the person. A more approachable solution these days is basically to train deep neural networks with real and fake data, and you can actually pretty well detect if something is a deepfake. And of course, there's a lot of commercial solutions out there. Here are two examples, one from Intel and one from Microsoft. But based on our experience, it's actually better to look at the research community. So there's a lot of advancement there as well. The other important thing is that we also need to raise awareness of the potential of deepfakes. So together with the World Economic Forum, we've actually developed the first real-time deepfake technology, basically to showcase, that was back in 2020, that it is possible to actually have live conversations with a fake person. So this was demonstrated back then, but at the same time, the idea wasn't really to have a company that actually creates deepfakes, but our initial goal was actually to enhance digital avatars and make them more real, right? So originally, the whole development was to create a better technology for building digital humans. On the left, what you can actually see, this is a standard output of a state-of-the-art game engine, in this case, the Unreal game engine, but just using a couple of minutes of additional training data, we can actually enhance the likeness of the person. So we actually moved on to a positive use case of these kind of technologies. So what our company is doing is basically we're using generative AI for visual effects. I'm going to show you a couple of interesting use cases. This is a use case for the movie Slumberland. So in the movie, you basically have a scene where a toddler is actually starting to speak. So we have one of the actors who's basically puppeteering the baby and make the baby speak. So I'm going to show you how this looks like.
Babies. Obviously.
Here's another example for a production with Netflix. So this is the TV show The Manifest. It went over 4 seasons, and one of the main characters actually grew up over the different seasons. But in the final season, they actually go back in time, and they wanted to see how the actor actually looked like, how he was as in the first season. So what we did is we use the film material from the first season and trained the model so that we can turn a digital double that you can see here on the left into the likeness of the double of the original actor on the right. Right? In Fallout, there is like a flashback scene where Kyle MacLachlan, the actor from the original Dune movie, had to look much younger, right? And this is also what we did in terms of like de-aging. So the process is we would take young film materials of the actor, train the model, and basically use the model to actually face replace and de-age his current age. So there's another very interesting use case, and that's actually the scalable market and the bread and butter for our company, which is, can we use this technology to augment actors and make actors speak any language they want? Right? So imagine you had a foreign movie. The only solution right now is you have to read subtitles if you don't understand the movie, or you have to deal with really bad dubbing. So the idea is, can we use these puppeteering technologies, facial reenactment, in order to AI lip sync the mouth movement? So that's actually what we did. We're actually the only company out there that has been able to AI lip sync entire movies using this technology. So this was back in 2022. There's a movie called The Champion. It's a Holocaust movie, and it's in German-Polish. And what we did is basically we changed the language into English.
Dass Boxen wie Schachspielen ist.
Rudi, ab ins Bett.
I've read that boxing is like playing chess.
Rudi, auf to bed.
I've read that boxing is like playing chess.
Rudi, auf to bed.
Right. And here's a recent work that we've done. We're actually doing a lot of like Netflix movies. This is a French action movie called AKA, and here you can see how we translate from French to English.
C'est quoi le problème?
Ok, bah je vais te dire c'est quoi le problème. J'avais une dette, une putain de grosse dette, j'ai dû leur lâcher le coup. Y a pas mort d'homme.
J'en ai rien à foutre de ta dette, moi.
Et maintenant, qui c'est qui a la plus grosse? Hein?
Je m'en bats les couilles, je repars pas sur les plombs.
Eh bah tu vas pas repartir du tout alors.
What's the problem?
Okay, Pee-wee, I'll tell you what's the problem. I owed these guys one fucking huge debt. I had to give them the scoop.
These things happen. Your fucking dad is not my problem.
Size matters, wouldn't you say, asshole? Huh?
I'm not leaving without those plans I told you.
Then you won't be leaving at all.
So one thing we're going to release also very soon is a new product called MBZUAI. And what it'll allow you to do is basically just upload your own video, and through our service, you'll be able to translate into any language. You can upload an audio track and AI lip sync your video as well. Or you can also type in any text words and then make the person say, new content. So here's an example of myself. Like, it's an old video, and I don't speak Spanish, so I wanted to see how I look like when I speak Spanish. So this is the result.
Y para mí lo importante era una ciudad genial y una buena escuela, y no hay muchos lugares como ese. USC es óptimo. Mi objetivo de investigación es llevar tecnologías de captura de rendimiento de Hollywood y laboratorios de investigación a todos para su uso en videojuegos, y para mí lo importante era una ciudad genial y una buena escuela, y no hay muchos
lugares. So the idea is that you would use these kind of technologies that we deploy in Hollywood and can use it for your own videos. Okay, so a lot of these examples actually focus on manipulating or generating the human face. But then there's a question of what if we wanted to generate anything we want, right? So this is the real power of generative AI. And one of the breakthroughs recently that enables this to happen are diffusion models, right? So you've probably heard a lot about stable diffusion. So the idea is that you would break down the general problem of generating content into multiple smaller problems. So the idea is that we would add noise into an image signal, and the generator become the denoising problem, which uses a deep neural network, right? So one thing that is really practical here is that you can actually facilitate the use of a text prompt using a text embedding so that you can actually generate any content you want, right? So a couple of examples here. For example, DALL-E 2, your prompt is a teddy bear cut toy poodle eating a bagel in Dubai would generate these images. That was shown a couple of years ago. Midjourney, right? Another text-to-image generation solution that's very popular. And of course, Runway ML, which for the first time showed kind of creepy videos that were generated from text. Back then, I thought it would take a couple of years to generate, any videos. But the progress is much faster than we think, right? So here's an example of Stability AI's stable video diffusion. So it generates very stable content, very consistent content. And of course, the current state-of-the-art OpenAI Sora. This is, the text prompt, a golden retriever doing certain things, and then you can actually see these extremely realistic videos. So this is the current state-of-the-art in terms of video generation. So of course, the content is still very difficult to control, but I'm pretty sure we're going to see a lot of advancements in this area. So as a final thing, I'm just going to show you one of the technologies that we're developing from my academic side at the university. We're seeing a lot of things, applications and visual effects, but I think one of a much bigger impact is if we can use this technology to enhance communication, right? So people are talking about virtual teleportation within, the application of metaverse. And this is an old concept video from Microsoft that is showcasing how people would collaborate, interact together remotely using virtual avatars. But unfortunately, one of the only solutions you can purchase these days, for example, using Meta's HeadQuest, is avatars that still look like video games from 10 years ago. So at the same time, they are also showing R&D developments that are extremely real, right? And the technology behind this are the same core technologies called neural renderings, which is similar to what people use for generative AI. The only problem with this kind of solution is that they require a huge capture setting in order to record an actor from hundreds of cameras and process the data over weeks. So what we're developing is a much more accessible technology that allows everyone to create realistic avatars from a single webcam photo. So this is the current state of the art. It's a technology called Voodoo XP. It generates a photorealistic avatar in 60 milliseconds. You use a webcam, you just take a picture, you instantly get your avatar. And in real time, you can drive it. So here, this is just to show that we can get very realistic a clone of a person. This is called self-reenactment. And we can take any photo of anyone and do what we call cross-reenactment, right? So I can take a photo of anyone and drive that person in real time. And what is important is that we can do a 3D-aware neural rendering, which means that you can generate consistent views from arbitrary views. So this is, the technology behind this is disentanglement. So what this allows you to do is to use this inside a virtual reality setting, where you basically generate your avatar from a single photo. You use this real-time head reenactment technology to basically communicate with the other person in real time using a standard VR headset. So to conclude my presentation, the take-home message here is that there's a lot of concerns in the visual effects, the entertainment, the VR community about what is possible, but at the same time, there's also a lot of excitement, right? Joe Russo, one of the directors from the Avengers, is predicting that in 2 years we're going to have entirely AI-generated movies. I think this is going to take a little bit longer, but I'm pretty sure that these tools are going to be heavily involved. And as of the current state of the art, Hollywood is somewhat ready, right? We're already deploying our AI lip sync technologies. Voice retargeting is used, and also, for digital doubles, de-aging, AI is really the tool of choice. But at the same time, when we talk about technology that can generate anything, diffusion model-based technologies, one of the key challenges there is how do you control the content, and also they still have very poor UX interfaces. Of course, this creates a lot of concerns because we can generate anything, and all these technologies are highly accessible to people. Of course, since COVID, a lot of the interactions are online, so we have to put a lot of concerns about how do we detect fake identities, forged content. And one of the recent studies from UCL basically shows that deepfakes are one of the most serious AI cybercrimes that are out there. Nevertheless, not everything is bad and controversial. And, like many actors, they're very excited about this technology, and I think we should all embrace artificial intelligence. Thank you so much. Thank you for your attention.